Frontier. This is number 12, and let's get right into it. So we're at 15 minutes from official market open, but let's kind of see what's happening. So SanDisk has really kind of taken a hit recently. We've kind of seen it just kind of like calm down a little, which is honestly healthy, and like we kind of see a lot of these kind of like pullbacks along the way. So to me, the thesis hasn't changed. Nothing's really changed. Just number is temporarily down, and that's part of the journey. Intel breathing. It kind of feels like a lot of things are just taking a breather, which is honestly like pretty healthy. ASML has been good. It's actually kind of like come up. It's kind of been range bound for ages. So the fact that it even hit 1600 is pretty good, but got dumped post market. Like you kind of look at this chart year to date, it's kind of just a flat line. AMD kind of chilling. Iron showing some strength, and Bloom kind of doing well. Nvidia just did well yesterday, given that certain chips are now approved to be sold in China. So we've got a bit of good momentum going on there. EWY, I think is down. Yeah, Samsung got dumped really hard, so we kind of see that being reflected. Our Korean friends have really pumped a major indice from 150 to 200. Pretty crazy if you ask me. Anyways, how are our data center friends doing? Pretty good across the board. Nebius had blowout earnings, and that chart has just been number go up. Pretty phenomenal. Like year to date, 154%. So, congrats to all the Nebius holders out there. And I say Nebius and not CoreWeave, because CoreWeave has not been as fun of a ride. I mean, it's up 54% year to date, but still majorly down. They need to fix their debt situation, because right now they're basically short compute. And what I mean by that is their contracts go with the implicit assumption that they will make compute will get cheaper and their fixed contract prices will net them more money, which is such a bad structure. Until they like figure out how to restructure their contracts, I'm kind of net bearish on them. Cool. Anyway, let's jump to Twitter, because there's actually quite a lot I want to get into. So, okay, Google reported TSMC is they want to become a major customer. So, MediaTek would lose that contract. Wonder what is happening to MediaTek. I feel like I need to update this watch list a little. MediaTek, let's go. See overview and How do I add symbol? Cool. Sweet. We will have that for the future. And what did it actually do? Cool, bit down. Anyway, nothing too much to get from there. Okay, I want to get through this article. It's quite a lengthy one, but we'll kind of get there in a second. I just want to see what's going on at a high level, and then we can jump right into it. There's also this thing that just came out, which is Kioxia, the Japanese memory manufacturer, plans a US like ADS listing. I don't know how that's different to an ADR, but they're doing phenomenal. The stock actually dumped after hours after reporting really great earnings, which is pretty normal nowadays. Let's add this to the watch list as well. Kioxia, there we go. Oops. It just got kind of like hammered a little. And a lot of these stocks actually kind of move in the same way as SanDisk, but 60% in one month is on par with our other memory names. Cool. Let's go. So they're gonna pay a bunch of bonuses to their workers. Claude usage. Anyway, let's go to our semis list so we can get a bit more of a targeted view. Sweet. Okay, so I don't know what like COT stands for. Let me just search out. What does COT stand for? customer-owned tooling. Okay, cool. Um, that roughly seems plausible. And yeah, if that happens, I wonder like how much outside of like TSMC certain fabs will retain in terms of earning power. Okay. Um, trip to China was a huge success. Jensen was able to aura farm and win the hearts and minds of the Chinese people. He's truly a special CEO. Jensen will get his licenses once she sees how he ate the street food of Beijing and connected with the people. Thank you for your attention to this matter. That's so good. Jensen is an absolute G. I love the guy. He has this like very nice grace to him. And yeah, I think NVIDIA has a bright future. The fact that you just have the whole gang on the Air Force One, I think, is it's kind of cute, to be honest. Anyway, dun dun dun. Today is the end of an era with Jerome Powell's final day as Fed chair. That is crazy. To be honest, like, despite what your political views are, it seems like the man gave it an honest shot, right? Like, he was like, hey, what do I do to make sure the trust in American institutions stays there and I'm doing the right thing? So, yeah, I feel like from here, it's kind of going to be crazy town. We're going to be probably lower rates, despite what the market will set rates at. It's a complicated matter. I don't think it's just like, oh, hey, we're bringing down rates and everything magically comes down. There's a lot of forces going on here. But yeah, Daniel Koss. Anyway, to be seen. Nebius can keep growing. I agree. It's like people need to pay expenses. Dun, dun, dun. Yeah, Nebius definitely feels like it could be the next hyperscaler. I personally think I'm underweight, and I want to build a position more in it. Like, I think the team's executed well. They've got their financing in check. Yeah. Yes, borrow against it. Cool. I don't know why he retweeted that, but anyway. Nothing beats the rush of a crazy Uber driver. Okay, don't know what that's about. That's insane. Cerebras is trading 134 times trailing revenue, which is more than 5 times Nvidia's multiple. And to me, this is kind of like the irrationality of the market. People would rather buy low quality businesses at like ridiculous multiples than the thing that actually makes money and is actually being valued by the market. This doesn't look like someone worried about disappointing the next NVIDIA earnings. When is NVIDIA earnings actually? Earnings. I feel like it should be pretty soon. May 20th. Okay, so we got that next week. Cool. Moving on. I don't think we should call Nebius a neocloud. Their full stack AI infrastructure puts them in a class of their own. Emerging hyperscaler, factory operator. I largely agree. I think Nebius's executive team has a lot of talent to actually make shit happen. Definitely bullish on them. SpaceX IPO. This is gonna be kind of crazy. Yeah, it's gonna be insane. Citi raises price target from 170 to 287. I mean, it's already at 220, so that's not too far off. This Micron DRAM TSM 2026, you need 12 HBM stacks per substrate. In 2029, you'll need 64. I just don't think people properly forecast how much demand there's going to be for memory. For all the bears that are like, oh, like we're going to build a few fabs in 2027, supply is going to come flood the market, and demand's going to dry up. I'm like, you genuinely do not know what you're talking about. Microsoft offers compelling value. I do see that. It's like Microsoft owns a lot of compute. That is for sure. I don't think their investments are bad necessarily. It's just some of those annoying things when the market hates a stock, they kind of just like needlessly hate it. I feel like, what was it? NVIDIA's kind of been through that recently, but now they're kind of breaking out. Cool. Holding winners versus trimming is complete nonsense. Yeah, that's the thing. I genuinely don't get it. Like people are just like, "Oh, it's good risk management to trim your winners." It's like, why would you sell your winners? The amount of money people have lost trimming winners is absolutely insane. I personally never really understand it. If you believe in the thesis, you believe in the company, why would you own less of it? Anyway, uh, they literally that's insane. Anyway, okay, let's get into this article because there is quite a lot to unpack. So, dun dun dun. Okay, rating AI supply chain bottlenecks, irrational analysis, insane analyst interview. So, here's my interview with irrational analysis. This is a lot to read, so I'm kind of just gonna skim and find the key parts. Dun dun dun. Okay. I actually think we're gonna probably need Claude to properly understand this, so let's just copy pasta this, because I don't want to like pretend like I understand everything here. This was one of those articles where I'm like, yep, I need to actually spend the time to go deeper here. So let's go, Claude. Can you break this down? Mid-level knowledge semis, just to be safe. And I hope you guys tuning in have some basic knowledge as well, but always happy to break things down in case I feel like they're a little advanced. Okay. Everything is constrained, but some bottlenecks are worse than others, and some are already priced while others aren't. So indium phosphide, lasers for optics, this is the one he's most alarmed about. Isn't the raw material, it's processing them into laser chips. Co-packaged optics is making it worse because CPO lasers need bigger die sizes with tighter specs. So EML, the traditional monolithic indium phosphide transceiver chip, is getting starved of supply, and the same fabs making EML are pivoting capacity to CW, continuous wave lasers, because they're higher margin. This is why silicon photonics is dominating 1.6 terabyte transceivers way earlier than usual. Not because silicon phosphide got better, but because there's no indium phosphide to make EMLs. This plays Lumentum, AXT, Extron. I wonder what AXT's on. I feel like it dipped recently. I feel like I also need to add this to the watch list here that we're tracking. That's crazy. Year to date, 5x. Went from 22. I wonder what the earnings are negative. Stock is 115. I mean, yeah, it's a bottleneck, but I just don't know how you hold a lot of this stuff. Maybe the forward looking is a little different. Like, okay, it's 7 cents here. I wonder what it's meant to be next quarter. What is management guided? Okay, 25 cents. That is pretty good. So, I mean, like, let's say they make even $1 in 2027 for the full year. It's still 100x. See, this is where I think, like, people, like the engineering side, I'm like, I get how this is a bottleneck, but how is this not priced? Anyway, DRAM, and basically it doesn't matter who does what, all DRAM HBM suppliers are going to expand massively. I'll actually go to the part of the interview where he speaks about this in more detail because I think it is worth actually going. I already skimmed this a little. Logic fabs. So TSMC doesn't have enough capacity. Power semis. So effectively, power plant no blow up forces flat GPUs to waste energy on junk calculations to keep power draw constant. That's insane and wasteful. Wow. So PyTorch is a machine learning library that a lot of people use, and the fact that they optioned power plant no blow up means that just to keep the draw constant. So he likes Wolf Speed, but he thinks it could 5x as a degen play. Solar Edge and OnPhase, solar microinverter companies down 90%. They're pivoting to solid state transformers. Let's check this chart out. Do we have? It feels like this is one of those plays where you have to believe management will turn around, and people aren't already bidding it up massively. Okay, kind of interesting. $50. EPS 2x4. So let's say make $10 of EPS. This actually seems kind of reasonable. I actually don't know enough about OnPhase, so let's kind of want to add this to the list. Add. Cool, and I think that is a little to-do list item here. Let's come back to that. Just pin that there. Okay, going back to Claude. Cool. Cerberus loves wafer scale concept, but it's critical. They're stuck on FP16. FP16 is a quantization. It's not really a quantization thing, but it's like, to what precision can your calculations go? And they're on FP16, but you want FP4 for good inference capacity. And their yield is really low, but he wants to be activist. Positron likes it. Thales, I don't know, to be seen. He says Semtech is his most exciting current holding. Doesn't make copper work better, but makes analog amplifiers, equalizers used in active copper cables, PCBs, linear pluggable optics, transceivers, and NPO. Duopoly with MACOM, blah, blah, blah. Yes, I agree. Neoclouds are bearish. So let's understand what's the deal with these ones. Oh, whoops. All right, so Semtech. So what happens when you send data between chips at high speed? When you push a signal at 200 gigabits over any medium copper or trace on a PCB and optical link, the signal degrades, gets weaker and noisier, and the clean opening between a 1 and 0 closes up. You need analog chips at both sides to fix this. Retimers, redrivers, linear amplifiers, and equalizers that clean the signal back up so the receiver can tell ones from zeros. The key insight from the interview is that Semtech makes these analog chips, and they're needed in basically every high-speed interconnect type, not just copper. So you need copper, PCB, linear optics, traditional transceivers, NPOs, and something else. So as data rate climbs and every link in the data center gets faster, Semtech sells into all of them. It's not a copper versus optic spec. They win either way because signal integrity is a problem everywhere. It's a duopoly with MACOM. He says he's looking at actual data sheets and using the parts. Semtechs are meaningful, better for his point about expert calls is important context. Hedge funds pay consultants for industry calls, and some business development person might say, we dual source between Semtech and MACOM, which sounds like 50-50, but the actual split in production is probably heavily skewed towards Semtech because the specs are better and the finance people don't dig deep enough to figure that out. Super cool. Let's see Semtech. What is the financial situation of these guys? Okay, EPS is growing, $2, nice. Let's say they make 10. Wow, this actually kind of seems pretty reasonable. I mean, of course, the best time to get in was April, but it is what it is. 96, 133. Cool. I mean, this is actually like one of the charts which I like. I also want to track this. Wow, okay, definitely some good alpha here. I'm going to keep these two to the left here, but it's not often which I come across names that I kind of am like, this smells the sniff test. So Semtech and OnPhase. Anyway, let's get back to it. But the fact that it's in analog, wait, how long has this company been around? Founded in 1960. Okay, this, to me, this is the stuff I love. I'm like, here's a company that's been doing something for decades. It's super niche and the entire world needs it. I'm like, cool, I'm a buyer. So, oh fuck, I closed the tab. Anyway, let's go back. Cool. Rigaku, how chip inspection works and why it's changing. When you manufacture chips and package them together, you need to inspect them to catch defects. Historically, optical inspection, shining light, analyzing the reflection image was good enough. Camtek and Onto Innovation are the big players here, but three things are converging that break optical inspection. Gate all-around transistors. The transistor is structured at 2 nanometer and below, wraps around the gate of the center of all channels. A critical feature is now buried in 3D structures that light can't see into properly. Backside power delivery. So, okay, basically he's saying that because the chips are 3D rather than 2D, you can't use light fully. Backside power delivery. Instead of routing power from the top of the chip, competing with signal wires for space, you flip it and deliver power from the back. Again, you now have critical structures hidden from top-down optical inspection. Cool. Tighter advanced packaging tolerances. As you stack chips closer together with finer pitch interconnects, so chip on wafer on substrate EMIB, this is what Intel does, this is what TSMC does. You need to verify alignment and bonding quality at resolutions optical can't reliably hit. X-rays go through materials so they can image buried structures, internal bonding quality, void detection, solder bumps, alignment of stacked dies, things light physically can't reach. Okay, so Rigaku made I don't know if I'm saying that correctly, but anyway, they made X-ray inspection tools that were bought in small quantities for R&D. A few machines per fab to help engineers figure out what was going wrong during process development. Now the same machines are becoming necessary on the production line at volume. That's totally different revenue trajectory, going from selling a handful of machines per customer to selling potentially dozens of hundreds. And given the rise of chip on wafer on substrate and EMIB, sounds like these machines are going to be massively helpful. So the Onto solution is the tell. Onto is the incumbent optical inspection company. If they thought their technology would remain dominant, they wouldn't go buy 27% of a potential competitor. Buying that stake and licensing their software onto Rigaku machines is basically admission. We can't build these X-ray tools ourselves, so we'll try to stay relevant by attaching our software to the hardware that's replacing us. His argument is, if you see that dynamic, just buy Rigaku rather than Onto. Okay, man, this is really good alpha. Yeah, fuck. Okay, I feel like I have some shopping to do after this. So, year to date, cool, 128. I mean, that's just the name of the game now, right? Like here, it is Taiwanese company, 800 to 3. So. Honestly, like, this isn't really crazy when you kind of look at relative to other names. Let's see what their earnings are looking like. So 60 Japanese yen. Oh, sorry, it's Japanese yen, not Taiwan. Duh. Anyway, so we got 60. Let's throw easy 4 to 40. Let's say 2,900 to 40. I just like to do this quick math. This is about a 12x forward. Assuming no growth, and like that is probably not true. So Feb 12th, 2027. What? How does that work? Do these guys just do earnings once a year? Is that how the Japanese market works? That doesn't seem right. Okay, so they give results. So, dun, dun, dun. Oh my god, the formatting here hurts my eyes. 55 yen EPS, is that? Let me just ask Claude. Parse the financials from Rigaku. Okay, so Q1 was ugly. Sales dropped 13, but they hit profitability. Operating profit collapsed massively. Net income fell, but the year-end forecast tells a different story. They're guiding 101 billion yen in sales, so 7% year on year, and operating profit is 16, and net income 10%. If Q1 did 18 billion in sales and 630 million profit, the full year target is 101 billion and 20 billion. So, operating margin of 22% versus 3.5. Okay. If Rigaku is genuinely transitioning from selling a few R&D tools per customer to production line volumes, you'd expect this pattern. Heavy upfront investment, cool, and revenue backlog. and EPS context. So 55 yen full year guidance at current share price. That gives you forward PE to figure out if it's priced in or not. Dividend is 20. It's a growth play. So yes, I do buy the thesis that advanced packaging will shift to X-ray inspection. Or am I wrong in my assumption? Give me the case for both. Okay, the case that X-ray wins. So the physics argument is straightforward and hard to agree with. Optical inspection works by bouncing light off surfaces. As long as there is the thing you need to inspect is on a surface and that features are larger than your wavelength limits, optical is great, fast, cheap, mature. But the industry is going 3D in multiple ways. Gate-all-around wraps, transistors, blah, 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 advanced packaging. And I think the Onto behavior, their largest competitor, is thing. Incumbents don't spend real money buying 27% of a niche competitor out of curiosity. That's a defensive move. I do agree. And TSMC's roadmap forces every major customer is moving toward these 3D structures. It's not a question of if, it's the announced production roadmap. And TSMC's yield requirements are extreme. They won't tolerate a blind spot in their inspection flow, especially on expensive multi-die packages where a single missed defect means scrapping thousands of dollars of silicone. I agree with that. Okay, so let's see the flip side. Why X-ray doesn't take over as fast or as bold things. Throughput is one thing. X-ray inspection is inherently slower than optical. You're shooting X-rays through materials, capturing transmission or diffraction images and reconstructing them, often in 3D. Optical inspection can scan a wafer insanely fast by comparison. Cost is related. The hybrid complementary scenario is probably more realistic than full displacement. Optical stays at a surface level, high-speed inspection where it works fine. X-ray gets added for specific stuff. In this world, Rigaku grows a lot, but Camtek and Onto don't die. The total inspection spend just grows with both technologies coexisting. Still good for Rigaku, but it's different magnitude than X-ray replaces optical. Plus, there's R&D risk, competitors. So the direction of the thesis is right. X-ray inspection in advanced packaging will grow significantly. The question is pace, degree, displacement, etc. And that's kind of like where management guiding like the quarters moving ahead. That's kind of where that revenue growth ramp comes from what I can basically tell. So I guess with this, right, you're in this interesting spot where you're like, okay, do I buy this like Japanese company that's kind of like turning around at this point in time? And I guess you kind of have to figure out like, do you want to go niche down into these other emerging markets? What is the upside? Let's see what the interview says. What does the guy from the interview say? And I mean the interview from the tweet, basically. He's bullish. He says optical inspection is getting broken by gate-all-around transistors, backside power delivery, and thing. So he says you have to use X-ray machines. You're screwed with optical. Not head jump maybe, but he sees it as a done deal. And he says that going from, that you need these X-ray machines, and the fact that like Onto is fucked. So he says that advanced packaging overall won't be as bad as people fear because Intel's ramping up a lot of capacity. But which semi-cap name is his favorite? Rigaku is the one he singles out as my favorite sort of specialty niche semi-cap. I love it. He doesn't treat the bear case, but I think that's the thing here, right? Like the thing that Claude says is like, well, we don't know if like advanced packaging will require X-rays for all the time, but the fact that he says there's actually 3 factors coming in at once, to me that makes it a lot more credible that you could see a ramp up in this technology or this like particular subsector. So I think it's a pretty solid play, to be honest. Like I definitely want to look into it more, or I mean, I don't know what there is to look into it more. Probably like a deeper dive onto the technology. Wait, where did that go? Let's just open that up. So, uh, did I just like forget how to spell it? No, that was it. Okay. I kind of want to understand a bit more. Okay, can we go deep here like we did, but for Semtech? Okay, so they basically ensure that physical connections between chips retains the signal. He says that Semtech is a copper cable company, but it misses the breadth. These analog conditioning chips are needed at every high-speed interface, regardless of the medium. In active copper cables, this is one everyone knows. So short-reach connections within a rack where copper is cheaper than optics. Semtech chips sit inside the cable ends as data rate goes up. You need more cables and more active electronics, even at a PCB traces level and co-packaged optics. So to me, this actually feels like a really good optics play without the crazy pricing. Copper versus optics is relevant to the thesis. Both need Semtech chips. I think this is such a fascinating point. The fact that Semtech and MACOM, his argument is that while customers will say they will dual source, the actual production favors heavily in terms of Semtech, and he says the story is almost mechanical, higher speeds all around. Margin is excellent. It's in the 60% north, and it isn't capacity constrained by the same bottlenecks hitting everyone else. They're not fighting for HBM or indium phosphide or advanced logic wafers. Analog chips are made on mature process nodes, older fabs with plenty of capacity, so they can actually scale to meet demand. And he says that if there's a small number of customers of hyperscalers in networking, but I don't know. I don't really see that. Like if everyone needs these interconnects between switches, I don't know. Anyway, integration risk. ASIC vendors, Broadcom, Marvell could integrate the retimer equalizer function into their new switch. This happened in other analog domains. Analog is hard to integrate than digital. It's not impossible. If Broadcom decides their next Tomahawk switch includes on-die signal conditioning for certain reach profiles, that eliminates a retimer socket. MACOM is still not standing still. The duopoly is real today, but they're investing aggressively. Semtech is way better. Could narrow. Valuation, cyclicality. Fuck this. This is bullshit. Revenue mix. He calls it fucking amazing and fucking everything. He says it's the most exciting holding from his trading account. He pushes back on the narrow copper play label and says people don't fully understand what they make. He sees the data sheets and uses the parts and considers Semtech clearly better than MACOM. He thinks there's a lot more room to run even after names in his book have already moved. Okay, whatever, Claude. I don't really care about what you think. So I think what we want to understand a bit more is why do ASICs pose a threat here? Pose a threat here. Aren't ASICs still using PCBs which will require the same technology? Sorry for my bad spelling, but I just like to type like that sometimes. Cool. The concern isn't that PCBs go away, it's a discrete retimer chip sitting inside the ASIC and the port gets absorbed into the ASIC itself. Right now, the signal path typically looks like this. Switch ASIC, PCB trace, Semtech retimer chip, PCB trace connector, cable optic. The Semtech chip in the middle is a separate piece of silicon on the board. The integration there is that Broadcom or whoever designs their next ASIC with thing, they don't need the retimer. So analog SerDes design is about link budgets. You have a certain amount of signal degradation across the channel, measured decibels of loss, and your SerDes has a certain amount of equalization capability to compensate. At 100 gigs per lane, some ASIC vendors could push their on-die SerDes hard enough to close the link without external help on short reaches. At 200 gig per lane and beyond, the loss budget gets so tight that even excellent on-die SerDes, I need to figure out what this means, loses. The physics get way worse with every speed jump. So integrating the retimer function on die is theoretically possible for short reaches, but as speeds keep climbing, the reach where you get away with external conditioning keeps shrinking. As in a data center, not every link is conveniently short. Rack to rack to row, these distances don't change just because SerDes goes faster. So the integration is real in theory, but probably limited in practice as the speeds of industry is heading towards. If anything, higher speeds make the case for more external signal conditioning, not less. How hard is it to make this component? How defensible, etc. is it? What makes them so good at it? Cool. So analog semiconductor design is one of the most defensible niches in the chip industry, and high-speed signal conditioning is among the hardest specialties within it. Here's why. Analog is fundamentally different than digital. Digital chip design is at its core about logic. You write code, RTL, and synthesized tools convert it into transistor-level layouts semi-automatically. A talented team with good EDA tools can design a competitive digital chip in a reasonable time frame. The tools do a lot of heavy lifting. Okay, so exploratory data analysis tools. Okay, analog doesn't work like that. There is no synthesis for analog circuits. Every transistor is hand-placed and hand-tuned by a circuit designer who understands how that specific transistor behaves on the specific process node at that specific operating point. The designer is thinking about the continuous voltage and currents, not ones and zeros. They're managing trade-offs between bandwidth, noise, linearity, power consumption, and stability. But the actual design is deeply manual and intuition-driven. This means analog experts live in people's heads, not in code bases or tool flows. A senior analog designer with 20 years of experience designing equalizers has built up intuition that cannot be transferred to a new hire through documentation. They know which circuit topologies work at which speeds, which parasitic effects will bite you at 50 gigahertz, etc. And when you're looking at high-speed signal conditioning specifically, at 100 to 200 gigabits per lane, you're operating at frequency where basically everything on the chip becomes an antenna, a transmission line, or a parasitic element that wasn't in your schematic. The boundary between circuit and electromagnetic structure blurs completely. Your designer needs to think like an RF engineer and a circuit designer simultaneously. Okay, so it's really fucking hard, basically. And Semtech has been doing it for a long time. They have the IP, they have many generations. And they have the relationships. So, vary but not indefinitely. The moat is deep on a 3 to 5 year time horizon. It would take a well-funded competitor, probably 2 full production generations, 4 to 6 years, but then they've moved further ahead. Macom is one of the MAC, I don't know how you say it. Anyway, they're credible, but he says that Semtech's parts are superior. In short, this is about as defensible as semiconductor businesses get outside of pure foundry monopolies like TSMC. The knowledge is tacit, the iteration cycle is long, and the performance gaps are measurable. The physics is getting hard in ways that favor the specialist. Boom. That's the case. Wow. That was a really good interview. I feel like we got a lot of alpha. I mean, have we missed any parts of that interview that we should look into further? I feel like I'm going to be going shopping after this. This is exactly the type of stuff that I love to find. Waiting. Okay. The CPU shortage, big problem. I don't really buy that. A really specific supply chain. CPU demand is eating indium phosphide, which makes EML makers relocating capacity to different lasers. Let's see, Tower Semi. Wow, I feel like this thing is run up. As in, I don't think the earnings are gonna make sense. Yeah, this feels like a crowded play. Bloom Energy, cool, agree. Vernova, high quality moat. Doesn't know where the further upside comes from. Agree. Broadcom's hidden laser business, possibly. High bandwidth flash. He says that it's not really going to solve a lot of problems. Okay, Nokia is a cheap Sienna. He's been in and out. Is a two-book system, long only and trading with margin. Trading book you can go to 0 and that's fine. That's how he tolerates volatilities of name like Wolfspeed. Cool. I said, what do you think his book is biggest on? I feel like it would be Semtech and Rigaku. Okay, Vernova, Lumentum. He probably got in this early. Lots of things on Intel, TSMC, meaningful but smaller. The trading account, which he's saying could go 0. So these are kind of like high risk plays that he's like, I can make some more money off. It's probably down on the rest, but cool. That was a good interview. I feel like I definitely learned a lot. I hope that you guys definitely did as well. Yes, that was a great read. Kioxia had earnings, dipped, great business. Probably gonna get the U.S. listing. Yeah. Huh. Anyway, this got pretty long today, but thank you all for tuning in. Hopefully you did enjoy going deep on a lot more of the technical stuff, and we'll catch you all next week for another week. Take care. Bye.